What if this exact moment never passes? Not metaphorically, physically. What if your 10th birthday is still happening right now, and your death has already happened, and both are as real as the breath you just took? This sounds insane. It also follows directly from the most successfully tested theory in the history of science. We assume time flows. The past is gone, the future hasn't arrived, and we ride the knife edge of the present between them. Nobody teaches you this. You absorb it before you can speak. It feels less like a belief and more like the floor under everything else you know. Relativity quietly pulled that floor away. When Einstein worked out how time behaves for objects in motion, he uncovered something almost nobody wanted to face. There is no universal now. Your present and a stranger's present can disagree about what is happening right now in a distant galaxy. And physics says both of you are correct. Push that logic hard enough, and it breaks the river completely. If someone else's present can contain your future, then your future already exists. And if it exists, time is not flowing anywhere. It is simply there, all of it, a finished structure we are crawling through one frame at a time. This idea has a name, the block universe, and it is not a fringe position. It is arguably the default reading of modern physics. What follows is the chain of reasoning that forces us toward it, the experiments that back it up, and the unsettling questions it leaves about choice, memory, and whether the future is already written. It starts with one stubborn problem. Nobody has ever found the flow of time. Nobody has ever measured the flow of time. Read that again because it sounds wrong. We have clocks everywhere. We have atomic clocks accurate to within 1 second over 30 billion years. We measure duration with absurd precision. But duration is not flow. A ruler measures distance, yet nothing about a ruler tells you that space is moving. Clocks are the same. They measure the gap between events. They say nothing about a present that slides forward. And when physicists go looking for that sliding present in their equations, they find nothing there at all. This is the quiet scandal at the center of physics, and most people never hear about it. The laws that govern the universe, Newton's mechanics, Maxwell's equations for electromagnetism, Einstein's relativity, the equations of quantum mechanics, contain a variable for time. They use it constantly, but in none of them does that variable single out a special value called now. There is no term in any fundamental equation that says this particular moment is the real one, and the others are memory or expectation. The equations treat every moment identically, the way a map treats every location identically. A map of a country does not mark one city as here. You bring the here when you stand somewhere. Physics increasingly suggests that you bring the now in exactly the same way. The universe does not contain it. Consider what that means by comparing time to space, because this comparison is the doorway to the entire idea. If I stand in a city and someone asks where the next town is, I might say it is ahead of me. But ahead is not a property of the town. It is a relationship between the town and my position and the direction I happen to be facing. Turn around, and the town is now behind me. Nothing about the town changed. The words ahead and behind describe my situation, not the landscape. Now ask whether the past and future might work the same way. Maybe gone and not yet arrived are not properties of events at all. Maybe they are just descriptions of where those events sit relative to you, the observer, at the particular moment you happen to be occupying. The event itself does not become more or less real depending on whether you have reached it. It simply sits at its own coordinate, the way the town sits at its own location, whether you have driven there or not. Our intuition rebels against this immediately, and the rebellion is worth taking seriously because it reveals where the illusion lives. The past feels gone in a way that distant places do not feel gone. You cannot visit yesterday. You can visit another city. So there must be a real difference, the intuition insists. But look closer at why yesterday feels unreachable. It is not that yesterday has been destroyed. It is that the rules of physics only let causes flow in one direction, and only let information accumulate in one direction. You cannot reach yesterday for the same reason a river cannot flow uphill. Not because uphill stopped existing, but because the dynamics forbid the trip. The unreachability of the past is a fact about travel and causation. It is not by itself evidence that the past stopped existing. Those are two different claims, and the entire question of the block universe turns on keeping them separate. There is a deeper problem with the flowing time picture, one that philosophers noticed long before relativity, and that has never received a satisfying answer. If time flows, it flows at some rate. Everything that moves moves at a rate, meters per second, kilometers per hour. So at what rate does time flow? The only available answer is 1 second per second. But that is not a rate. That is just the statement that a second equals a second, which is true of every quantity and tells you nothing. Ask how fast a length is long, and you get the same empty answer. The flow of time, when you press on it, dissolves into a phrase that cannot be made to mean anything measurable. A genuine physical process can be quantified. The flow of time cannot be, and that failure is a clue that we may be describing something that is not actually out there in the world. So where does the overwhelming sense of passage come from? Because it is overwhelming. Every waking second testifies to it. The leading answer, which we will develop in detail later, is that the flow of time is something the brain manufactures, in the same way the brain manufactures the smoothness of motion in a film made of still frames. A film is a sequence of fixed images. Nothing in the strip of film moves. The motion appears only inside a viewer, when the images are presented in order and the mind stitches them together. The block universe proposes that reality is the film strip, a complete static sequence of moments, and that consciousness is what runs through it, generating the sensation of flow from material that is itself entirely still. That is a startling reversal. It says that the most certain thing we know, the passage of time, is the product rather than the cause. It says the river is in the eye, not in the world. And before dismissing it, remember how often this exact reversal has happened in the history of science. The Earth feels stationary while the sky moves. In fact, the Earth spins and races around the sun. The sun feels like it travels across the sky. In fact, our own rotation creates the entire effect. The ground feels solid. In fact, it is mostly empty space studded with atoms. Over and over, the thing that felt most obvious turned out to be a feature of our viewpoint, rather than a feature of reality. The flow of time may be the largest example of this pattern that exists. It would be strange if every other intuitive certainty fell, and this one alone survived untouched. But intuition deserves a fair hearing before we set it aside. So consider the strongest version of the objection. When you decide to raise your hand, you feel the future being created. The hand was not raised, now it is. Surely that act of creation is the flow of time made visible. The block universe answers that what you experienced was a transition between two fixed states that both already existed in the structure. The state with your hand down and the state with your hand up. And that your sense of creating one from the other is exactly the sensation we would expect a conscious system to have as it moves along its own timeline, regardless of whether the timeline is being written in real time or was complete from the start. The feeling is identical in both cases. And if a feeling would be identical whether or not time flows, then that feeling cannot be used as evidence that it does. This is the move that physics keeps forcing on us. We must separate what we feel from what the equations and experiments actually require. None of this proves the block universe yet. So far, it only opens a door by showing that the flowing river is an assumption rather than a discovery, and that the assumption has cracks in it that have never been sealed. To turn the open door into a forced conclusion, we need something stronger than philosophy. We need a result so solid it cannot be argued away, a piece of hard physics that does not merely permit the block universe, but actively demands it. That result exists. It came from a patent clerk in 1905 who was thinking about light and motion, and who noticed that two people moving differently cannot agree on when things happen. To see why that single fact dismantles the universal present, we have to start where he started, with the strange and stubborn behavior of clocks that refuse to tick the same. But first, we need to understand the picture he was about to overturn. The version of time that ruled science for 2 centuries and still rules the inside of your head. For 200 years, time had a master, and his name was Isaac Newton. When Newton built the framework that would describe the motion of everything from falling apples to orbiting moons, he needed a foundation to put it on. And the foundation he chose was a particular vision of time so confident, so absolute, that it shaped the imagination of the entire scientific world. He wrote that time flows equably, without relation to anything external. Read those words carefully. He is saying that time is a thing in itself. It does not depend on the stars, on motion, on observers, on events. It simply flows uniformly, everywhere at once. The same for every object in the cosmos, whether anything is happening or not. Strip the universe of all its matter, empty it completely, and Newtonian time keeps ticking in the void. A cosmic metronome that needs no orchestra to keep its beat. This was the universe as a single grand clock. There was one true present moment, and it stretched across all of space simultaneously. When it was noon for you, there was a definite objective fact about what was happening at that same instant on the far side of the galaxy. The word simultaneous had a clean, unambiguous meaning. 2 events either happened at the same moment or they did not, and any disagreement was merely a failure of measurement, never a failure of the concept itself. Get better clocks, synchronize them carefully, and everyone in the universe would agree on the order and timing of events. The present was a sheet that sliced cleanly through all of reality, dividing the dead past from the unwritten future. And that sheet advanced at the same steady pace for the king and the comet alike. It is worth pausing on how natural this feels, because Newtonian time is not just a historical theory. It is the time that lives in your skull right now. When you imagine your friend across the country sitting down to dinner while you brush your teeth, you are assuming there is a real, shared now connecting you. When you picture an event happening light years away at this very instant, you are using Newton. The intuition is so deep that for most of human history, nobody thought to question it, because nothing in ordinary experience ever contradicts it. At the speeds and distances of normal life, Newtonian time works flawlessly. It got us the laws of motion, the law of gravity, the prediction of planetary orbits, the return of comets on schedule. It put the framework under the entire scientific revolution. A theory that successful earns its confidence. And yet, There was a man who disagreed, even at the height of Newton's triumph, and his objection turned out to be a preview of everything to come. Gottfried Leibniz, Newton's great rival, refused to accept that time could be a container existing independently of events. To Leibniz, time was nothing but the order of happenings, the relationships of before and after among real events. Take away the events, and you do not have empty time ticking in the dark. You have nothing, because time was never a thing in the first place, only a way of cataloging how occurrences relate. If two universes were identical, except that one had been created 5 hours earlier in the great cosmic clock, Leibniz argued, there would be no possible difference between them, no observation that could ever tell them apart, and so the supposed difference was meaningless. The 5-hour head start referred to nothing real. This was a relational view of time, and it lost the argument in its own century, overwhelmed by the staggering practical success of Newton's absolute framework. But Leibniz had planted a seed. He had suggested that time might not be a stage on which events play out, but rather a summary of the events themselves. 200 years later, that seed would grow into the structure that buried absolute time for good. The cracks did not appear in the study of time at all. They appeared in the study of light. And this is one of the genuine surprises in the history of science, that the overthrow of Newtonian time came not from anyone questioning time directly, but from people trying to understand how light travels. Through the 1800s, physicists worked out that light is an electromagnetic wave, a ripple in electric and magnetic fields, and James Clerk Maxwell captured this in a set of equations of breathtaking elegance. But the equations had a peculiar feature. They predicted a specific speed for light, a fixed number, written into the structure of electromagnetism itself. And that immediately raised a question that should have been simple to answer. Speed relative to what? Every other speed in physics is relative to something. A car travels at 100 kilometers per hour relative to the road. Throw a ball forward inside a moving train, and the ball moves slowly relative to you, but very fast relative to the ground outside, because your speed and the ball's speed add together. This is the most ordinary fact about motion, so ordinary that stating it feels unnecessary. Speeds combine. A thrown object inherits the motion of whatever launched it. So when Maxwell's equations specified a speed for light, the natural assumption was that this speed must be measured relative to some medium, some invisible substance filling all of space through which light waves rippled, the way sound ripples through air. Physicists named this medium the luminiferous ether, and they set out to detect it. The Earth, after all, is hurtling around the sun at 30 kilometers per second. As it plows through the ether, there should be an ether wind, and light should travel at slightly different speeds depending on whether it moves with that wind or against it, exactly as a swimmer crosses a river faster going downstream than up. The experiment to measure this was performed with extraordinary care by Albert Michelson and Edward Morley in 1887, using an apparatus sensitive enough to detect even a tiny difference in light's speed in different directions. They split a beam of light, sent the halves on perpendicular journeys, and recombined them, watching for the telltale shift that the ether wind would produce. They found nothing. The speed of light was the same in every direction, regardless of how the Earth moved through space. They repeated the experiment at different times of year, when the Earth's motion pointed different ways. Still nothing. The result was not a small discrepancy to be ironed out. It was a flat, total absence of the effect that the entire framework demanded. Light did not behave like the ball on the train. It did not pick up the motion of its source or the motion of the observer. It simply traveled at its fixed speed, always for everyone, no matter what. This was a genuine crisis, and it is important to feel the weight of it. A result like this does not just contradict a theory, it contradicts common sense at its root. Imagine running alongside a beam of light. Run faster and faster, approaching its speed. Surely the light should appear to slow down relative to you, the way a car beside you on the highway appears nearly motionless when you match its speed. But the experiments said no. Chase light as fast as you like, and it still races away from you at exactly the same speed as if you were standing still. The light does not care how fast you move. There is no catching it, no gaining on it, no slowing it down. Physicists spent nearly 2 decades trying to patch the old framework, proposing that objects physically contracted as they moved through the ether by precisely the amount needed to hide the wind, inventing increasingly elaborate fixes to preserve absolute time and space. The fixes grew uglier and the contradictions sharper. Then a young patent clerk in Switzerland, examining clocks and trains in his spare time and reading the same troubling results, made a decision that almost nobody else was willing to make. Instead of treating the constant speed of light as a problem to be explained away, he accepted it as a fundamental truth and asked what the universe must be like for it to hold. If the speed of light is genuinely the same for every observer, no matter how they move, then something else has to give. Something we had assumed was rigid and absolute must actually be flexible. Einstein realized that the casualty would not be light. The casualty would be time itself. To keep the speed of light constant for everyone, the steady, universal, equably flowing time of Newton had to be sacrificed. And once it was sacrificed, the shared present moment that connects all of reality, the very thing that makes the flowing river of time possible, would begin to come apart in ways that nobody had imagined. The first thing to break would be the most basic assumption of all, that 2 clocks, properly built, must always agree. The thing that broke first was simultaneity, and it broke in a way so precise that you can follow the logic step by step and watch the universal present collapse in front of you. Einstein's reasoning here is not vague philosophy. It is a tight, almost mechanical argument, and once you accept its single starting assumption, that light travels at the same speed for everyone, the conclusion is unavoidable. 2 events that happen at the same time for one observer happen at different times for another. Not because someone's clock is wrong, not because of measurement error, because there is no fact of the matter about what same time means until you specify who is asking. The classic way to see this is the train. Picture a long railway carriage moving down a track at high speed, and imagine a passenger standing exactly at its center. At the precise instant, the center of the carriage passes a person standing on the platform. 2 bolts of lightning strike, one at the front of the carriage and one at the rear, scorching marks into both the train and the platform. So there is a permanent record of where they hit. Now ask a simple question. Did the 2 strikes happen at the same time? For the person on the platform, standing equidistant from the 2 scorch marks on the ground, the answer is yes. The light from both strikes travels the same distance to reach them and arrives at the same moment. They see 2 simultaneous flashes. They are entirely correct. But the passenger at the center of the moving carriage tells a different story, and here is where it becomes precise rather than merely strange. While the light from the 2 strikes travels inward toward the center of the train itself is moving forward. The passenger is therefore rushing toward the point where the front light originated and away from the point where the rear light originated. The light from the front has less distance to cover before it reaches the passenger, because the passenger is closing in on it. The light from the rear has farther to go because the passenger is fleeing from it. And since light travels at the same fixed speed in both directions, this is the assumption we are not allowed to break. The front flash reaches the passenger first. The passenger sees the front strike before the rear strike. To the passenger, the lightning did not strike simultaneously at all. The front was struck first. Now confront what has just happened, because it is easy to slide past it. The instinct is to say one of them is right and one is wrong. The platform observer sees the truth, and the passenger is fooled by motion. But Einstein's point, the point that the experiments force on us, is that there is no privileged observer. Neither frame of reference is the true one. The laws of physics work identically for the passenger and the platform observer. Nothing in the universe marks one of them as the real stationary reference and the other as the diluted moving one. The passenger has every right to consider themselves at rest, with the platform rushing backward past them. From that equally valid perspective, the front strike genuinely happened first. There is no further fact, no cosmic referee, that can settle who is correct, because both are correct within their own frame, and frames are all there are. Simultaneity is not absolute. It is relative to motion. Two events separated in space simply do not have an objective, observer-independent ordering in time. Sit with the consequence, because the consequence is enormous. The shared present moment, the sheet of now that Newton stretched across the whole universe, the thing that lets you believe there is a definite fact about what is happening right now on a distant world, does not exist. Different observers slice the universe into present moments differently. What is now for you includes a particular set of events across all of space, but a person walking past you, moving relative to you, has a now that includes a slightly different set. Your present and their present are tilted relative to each other. Two different cuts through the same reality. And if there is no single present that everyone shares, then the whole machinery of the flowing river starts to seize. The river requires a now to be the leading edge of the flow. Take away the universal now, and you have taken away the one thing the river cannot do without. This is not a tale of subjective perception, and that distinction matters more than almost anything else in the argument. Because the easy dismissal is to say it is all just a trick of when the light reaches your eyes. It is not. The disagreement survives even after every observer carefully corrects for the travel time of light. The passenger does not naively report what hits their retina. They calculate, accounting for the finite speed of light and their own motion, exactly when each strike occurred in their frame, and after all corrections are made, they still conclude the strikes were not simultaneous. The platform observer does the same and concludes they were. The disagreement is not about signals arriving late. It is about the structure of time itself. Two competent physicists, each with perfect instruments, each correcting flawlessly for every delay, arrive at contradictory answers about whether two events happened at once, and both answers are right. That is the content of relativity, of simultaneity, and it has been confirmed in countless forms. The confirmations are not subtle or theoretical. They are mechanical, repeated, and woven into technology you use every day. The clearest example travels in your pocket. The satellites of the Global Positioning System carry atomic clocks, and they move at thousands of meters per second relative to the ground, while sitting in weaker gravity high above the Earth. Relativity predicts that their clocks will run at a different rate than identical clocks on the surface. The motion slows them down. The weaker gravity speeds them up, and the two effects do not cancel. The net result, is that each satellite clock gains roughly 38 microseconds per day relative to the ground. That sounds negligible. It is not. The positioning system works by timing signals to within billionths of a second, and an uncorrected error of 38 microseconds a day would corrupt your location by about 10 kilometers within 24 hours, growing worse every day after. The engineers who built the system had to program the relativistic difference directly into the satellites, deliberately setting their clocks to tick at the wrong rate on the ground so that they would tick correctly in orbit. Every time a navigation app places you on the correct street, it is silently confirming that time does not flow at one universal rate. The relativity of time is not an exotic prediction confined to laboratories. It is infrastructure. There are more direct demonstrations still. In 1971, physicists carried atomic clocks aboard commercial airliners and flew them around the world, eastward and then westward, while identical clocks remained at the observatory on the ground. When the traveling clocks returned, they disagreed with the stationary ones by precisely the amount relativity predicted. The flying clocks had recorded a different elapsed time than the clocks that stayed home. The crews and the clocks had aged by slightly different amounts. Not metaphorically, measurably. The effect grows extreme for particles moving near the speed of light. Certain unstable particles created in the upper atmosphere by cosmic rays should decay so quickly that they could never reach the ground. Yet they arrive in abundance, because their internal clocks run slow from our perspective, stretching their brief lives just long enough to complete the journey. From the particle's own perspective, its life is as short as ever, but the distance to the ground is compressed. Both views agree on what actually happens. The particle reaches the surface, while disagreeing entirely about how much time and space the trip involved. Time and space have become negotiable, traded against one another depending on motion, with only the speed of light held fixed for all. So time dilates, simultaneity dissolves. The universal present evaporates. Each of these results, standing alone, is a hammer blow to the Newtonian clock. But Einstein's former teacher, a mathematician named Hermann Minkowski, looked at this growing pile of strange effects and saw something his student had not yet fully articulated. He realized that all of these phenomena, the relativity of simultaneity, the stretching of time, the contraction of length, were not separate oddities to be memorized one by one. They were shadows cast by a single deeper object. If you stopped treating space and time as two different things and instead fused them into one unified four-dimensional structure, every paradox snapped into focus as a simple geometric fact. The disagreements between observers were no more mysterious than two people describing the same object from different angles. And the moment space and time were welded into a single fabric, that fabric would turn out to have a shape, a fixed, total, four-dimensional shape containing every event that has ever happened or ever will. To understand what Minkowski built, we have to stop thinking of time as something that passes and start thinking of it as a direction you can point in. Stop thinking of time as something that passes. Think of it as a direction, like north or up. This is the conceptual leap Hermann Minkowski demanded in 1908, and it is the hinge on which the entire block universe turns. He stood before an assembly of scientists and declared that space by itself and time by itself were destined to fade into mere shadows, and that only a union of the two would preserve any independent reality. It sounded like rhetoric. It was mathematics. What Minkowski had discovered was that the bizarre results of relativity stopped being bizarre the instant you stopped treating space and time as separate arenas and started treating them as two aspects of one four-dimensional whole, a structure that came to be called spacetime. To build the idea, start with something familiar and add to it one piece at a time. Locate any point in a room and you need 3 numbers. How far along, how far across, how far up. 3 numbers, 3 dimensions of space. This is ordinary and uncontroversial. Now suppose you want to specify not just a place, but an event. Something that happens. A hand clap, a flash, a collision. A place alone is not enough, because the same place hosts different events at different times. The corner of the room is empty at one moment and occupied the next. So to pin down an event completely, you need a 4th number alongside the 3 spatial ones, when it happened. 4 numbers locate any event in the history of the universe. 3 for where, 1 for when. Minkowski's insight was to treat that 4th number not as a label hovering outside the geometry, the way Newton did, but as a genuine coordinate inside a unified 4-dimensional space, fully on par with the other 3. Time became a direction within the structure rather than a current flowing through it. The consequence of that move is the heart of everything. In this 4-dimensional space-time, an object is not a thing that exists at one moment and then moves to the next. An object is a complete shape extending through the time direction, just as a road extends through space. Picture your own life. You were born at a certain place and time. One event, one point in the 4-dimensional structure. Right now, you occupy another point. Your death will be another. String together every event of your existence, every instant from first breath to last, and they form a continuous line threading through space-time, a line that physicists call your world line. You are not a single point moving along that line. In the 4-dimensional picture, you are the entire line all at once, a long and intricate thread stretching from birth to death, fixed in place. The infant, the adult, the elderly person you may become are not successive states that replace one another. They are different segments of one unbroken shape, all equally part of the structure, all there. This is where the loaf of bread becomes useful, and it is worth being precise about the analogy because it carries the whole idea. Imagine the entire 4-dimensional universe as a single solid block, a loaf of bread sitting on a counter. The 3 dimensions of space are squashed, for the sake of visualization, into the 2 dimensions of a slice's face and the long dimension of the loaf, running from one end to the other, is time. Now take a knife and cut a single thin slice. That slice is a moment of now, a complete snapshot of all of space at one instant. The slice just behind it is the previous moment. The slice just ahead is the next. Stack all the slices in order, and you have the full history of the cosmos, from the first instant to the last, baked into one motionless object. Nothing about the loaf changes. The slices do not come into being one after another. They are all already there, pressed together, the past slices and the future slices equally solid, equally real, distinguished only by their position along the length of the loaf. Time in this picture is not a process, it is an axis. The future is not waiting to be created any more than the far end of the loaf is waiting to be baked. It is done. It is sitting there. We simply have not encountered it yet, the way a traveler has not yet reached a city that nonetheless exists in full while they are still on the road. Now the strange results of relativity reveal themselves as nothing more than geometry, and this is the payoff Minkowski promised. Remember the train, where the passenger and the platform observer disagreed about which lightning strike came first. In the loaf picture, that disagreement is simply a disagreement about how to cut the slices. The platform observer slices the loaf one way, perpendicular to its length, and gets a particular set of events bundled into now. The moving passenger, because of their motion, slices the loaf at a slightly tilted angle, and that tilted cut sweeps up a different set of events into their now. Two knives, two angles, two different slices through the very same loaf. Neither slice is the correct one. They are just different cross-sections of a structure that does not privilege any single way of being cut. The relativity of simultaneity, which seemed to threaten the foundations of reality, turns out to mean only that there are many valid ways to slice a loaf that was sitting there whole the entire time. The events were always present in the block. The observers merely grouped them differently. And once you see that the disagreements are about slicing, the deeper truth becomes hard to avoid. If your now is one tilted slice and a passing stranger's now is a differently tilted slice, then events that lie in your future may lie in the stranger's present, and events in your present may lie in someone else's past. For these slices to disagree in a consistent way, the events they carve up must already exist as part of the loaf. You cannot tilt a knife through bread that has not been baked. The very fact that different observers can validly disagree about the ordering of distant events requires that those events be real, sitting in the structure, available to be sliced from more than one angle. The relativity of simultaneity does not merely permit the block universe, it seems to insist on it. A flowing universe with a single advancing present cannot produce observers who slice time at different angles, because a single advancing present allows only one slice at a time. The disagreements are only possible if the whole loaf is there. There is a precise quantity that makes this geometry rigorous, and it deserves mention because it is what gives the four-dimensional fabric its genuine reality, rather than leaving it a mere picture. Observers disagree about durations of time and about lengths in space. The moving clock runs slow, the moving ruler shrinks. These quantities are not absolute. They shift from frame to frame, like the apparent size of an object seen from different distances. But Minkowski found that a particular combination of space and time separations, woven together in a specific way, comes out identical for every observer no matter how they move. This invariant quantity, the space-time interval between two events, is the true frame-independent distance through the four-dimensional fabric. It is the thing all observers agree on even when they agree on nothing else. Its existence is what proves that space-time is not a convenient bookkeeping trick, but a real geometric object with a real structure. The disagreements about time and space are like the disagreements of people measuring a building's height and width from different angles. The building's actual diagonal, fixed and shared, is the space-time interval. There is a real four-dimensional shape underneath all the perspectival confusion, and the shape does not change. This is the universe Minkowski handed to physics, a single, complete four-dimensional structure in which all events have their permanent address, in which time is a direction rather than a flow, and in which the sense of a moving present is a feature of observers cutting slices rather than a feature of the fabric itself. Einstein, who had at first regarded his teacher's geometric reformulation as superfluous mathematical dressing, came to see it as essential, so essential that he could not have built his next and greater theory, the theory of gravity, without it. The block was no longer a philosopher's speculation. It was the natural reading of the best physics on Earth. Yet a picture, however elegant, is not a proof. We still need to show that this is not merely one permissible way to describe relativity, but something the theory forces upon us. And there is a single thought experiment, devised decades later and resting on nothing more than two people strolling down an ordinary sidewalk, that tightens the logic to the point where the future's existence becomes nearly impossible to deny. Two people stroll down an ordinary sidewalk, passing each other, one walking toward a distant galaxy and one walking away from it. They are side by side for an instant, occupying nearly the same point in space, moving at a few kilometers per hour, the speed of a casual walk, nothing exotic. And in that instant, according to relativity, their two versions of what is happening right now in that distant galaxy differ by days, by weeks, possibly by years. This is the Andromeda paradox, formulated by the physicist Roger Penrose, and it is the moment the abstract geometry of the loaf reaches down and grabs you by the collar, because it takes the dissolution of the universal present and stages it not with lightning and trains, but with the most mundane scene imaginable. Here is how the impossible-sounding result emerges from the modest setup. Recall that motion tilts an observer's slice of now through the four-dimensional structure. The faster you move and the farther away the event in question, the more pronounced the tilt becomes. For the train passenger and nearby lightning, the tilt produced a disagreement of fractions of a second, too small to notice without instruments. But the tilt does not stay small when the distance grows. Its effect multiplies with distance, and the Andromeda galaxy lies about 2.5 million light-years away, an almost unfathomable separation. At that range, even the gentle tilt produced by walking speed sweeps the slice of now across an enormous span of the galaxy's history. The two pedestrians, differing in velocity by only a few kilometers per hour, end up with planes of simultaneity that, when extended all the way out to Andromeda, are separated by a gap of days or more in that galaxy's timeline. One walker's now in Andromeda contains an event. The other walker's now, at the very same moment here on the sidewalk, contains an event from substantially later in Andromeda's history. Make it concrete. Suppose that in the Andromeda galaxy, a great fleet is preparing to launch an invasion, and the decision to depart will be made on a particular day. For the pedestrian walking in the direction of Andromeda, the now slice tilts so that the fleet has already launched. The decision is in their present, an accomplished fact sitting in their plane of simultaneity. For the pedestrian walking the opposite way, at the same instant on the same sidewalk, the now slice tilts the other direction, and in their present, the fleet has not yet launched. The decision lies still in the future, undecided, unmade. Two people brushing shoulders on a street corner, and for one of them, an event millions of light-years away has definitely happened, while for the other, that same event has definitely not yet happened. They cannot both be describing a present in which the launch is still an open question. For one of them, it is settled, and there is no privileged frame to declare which of them is right, because, as we have seen, the laws of physics refuse to single out either walker as the true observer. Now press on the logic, because this is where it becomes nearly inescapable. If for the first walker the fleet has already launched, then the launch is a real, definite event. It sits in their present as a fact. But that same launch lies in the future of the second walker. So an event that is in someone's future is, for someone standing right next to them, an already existing fact of the present. The future event must therefore be real. It cannot be an open possibility, a not yet determined branch, a region of reality still waiting to be filled in. Because if it were merely possible and undetermined, the first walker could not have it sitting as an accomplished fact in their present. The two perspectives are equally valid. Physics grants neither any special authority, and the only way both can be valid simultaneously is if the event exists in the four-dimensional structure regardless of which walker is considering it. The future, in other words, is already there. It has to be, or the perfectly ordinary disagreement between two pedestrians would be impossible. This is the argument, sometimes called the Reitdijk-Putnam argument, after the philosophers who developed it formally, and its power lies in how little it assumes. It does not require near light-speed travel or laboratory exotica. It requires only that relativity be true, which is among the best established facts in all of science, and that there be no preferred frame of reference, which is the very core of relativity. From those two granted premises, the conclusion follows by simple steps. If your present can contain, as a settled fact, an event that lies in your neighbor's future, and if neither of you holds a privileged view, then that event is real for both of you, which means future events are as real as present ones, which means the future already exists. The block universe is not smuggled in, it is derived. The reasoning chains together so tightly that to escape the conclusion, you must reject one of the founding principles of relativity itself, and no experiment has ever given anyone grounds to do that. The instinct to resist remains strong, and the most common form of resistance deserves a direct answer because it sounds reasonable. Someone might object that the two walkers cannot actually see Andromeda as it is now. They see it as it was 2.5 million years ago, since that is how long the light has taken to arrive. So all this talk of their differing presence in Andromeda is meaningless, the objection goes, because neither of them has any access to Andromeda's present at all. But this misunderstands what the argument claims. It is not about what the walkers can see or know. It is about what is real. The argument concerns the structure of spacetime, not the arrival of information. Each walker, after carefully accounting for the travel time of light, can calculate which distant events belong to their plane of simultaneity, which events their notion of now assigns to the same instant as their step on the sidewalk. The disagreement is in those calculations, in the objective slicing of the four-dimensional structure, not in their telescopes. The light delay is real and prevents them from observing Andromeda's present, but it does nothing to dissolve the fact that their two presents, correctly computed, disagree. The unreachability of the information does not make the event less real. It only makes it invisible, and invisible is not the same as non-existent. A subtler objection cuts deeper and is worth taking seriously, because it has occupied philosophers since the argument was first published. Simultaneity, one might say, is not a real relationship between events at all. It is a mere convention, a bookkeeping choice. And so the fact that two walkers assign different events to their now carries no weight about what exists. On this view, calling a distant event present is just a way of labeling, and labels do not create reality. This is a genuine philosophical position, and it cannot be dismissed in a sentence. But notice the cost of adopting it. To deny that the walkers' disagreement says anything about reality, you must hold that being present, being real, and existing are all relative to a frame of reference. That an event can exist for one observer and not exist for another, with no fact of the matter beyond each frame's say-so. That is not a rescue of the flowing river. It is an even stranger picture, one in which existence itself fragments across observers. Either the future events are real for everyone, which gives you the block universe directly, or existence becomes relative to motion, which abandons the single shared reality that the flowing river was supposed to protect. Both roads lead away from the comfortable Newtonian present. There is no path back to a single advancing now that all observers share, because the experiments have already shown that no such now exists. So the philosophy and the physics converge on the same destination. The relativity of simultaneity is not a quirk of perception, but a structural feature of a four-dimensional reality. The Andromeda paradox shows that this structural feature, pushed only a little, makes the future as real as the present. And if the future is real, then the past, by exactly the same reasoning running the other direction, has never ceased to be real either. Every event sits in the loaf, permanent and complete. Yet the moment we accept this, a contradiction with ordinary experience rears up that we cannot ignore. If past and future are equally real, equally fixed, equally there, then why does time feel so utterly different in the two directions? Why can we remember the past, but not the future? Why do things break and never unbreak, age and never grow young, scatter and never spontaneously gather? The block universe says the two directions of time are alike. Every fiber of experience screams that they are not. That contradiction has a name, and resolving it will take us out of the geometry of spacetime and into the deepest puzzle in physics: the question of why time has an arrow at all. Here is the contradiction stated plainly. The block universe says the two directions of time are identical. Past and future are just opposite ends of the loaf, no more different from each other than left is from right. Yet nothing in your experience is more obvious than the difference between them. You remember yesterday and not tomorrow. A dropped glass shatters. Shattered glass never leaps back together. You grow older, never younger. Heat spreads from the hot cup into the cool room and never gathers itself back into the cup. In every case, time has a direction, an arrow pointing firmly from past to future, and the reverse never happens. So if the fundamental structure of reality treats both directions the same, where does this overwhelming one-wayness come from? This is the problem of the arrow of time, and it is, by a wide margin, the deepest unresolved puzzle standing between us and a full understanding of why time seems to flow. Begin with the fact that makes the problem so acute, because it is genuinely startling once you grasp it. The fundamental laws of physics do not distinguish between past and future. Take Newton's laws of motion, or Einstein's equations, or the equations of electromagnetism, or even the core equation of quantum mechanics. Every one of them works identically whether time runs forward or backward. Film a collision between two billiard balls, then run the film in reverse, and the reversed film shows another perfectly legal collision. Nothing in the laws of motion is violated. Watch two atoms bounce off each other, reverse the recording, and the reversed version obeys every physical law just as faithfully as the original. The equations are, in the technical term, time-symmetric. They contain no preference for one direction. If you handed the equations to a physicist and asked which way time was running, they could not tell you, because the equations themselves do not care. This is profoundly at odds with experience, and the clash could not be sharper. At the level of individual particles, physics sees no arrow. At the level of everyday life, the arrow is everywhere and unmistakable. Films run backward are instantly recognizable as wrong. The diver leaping feet first out of the pool and back onto the board. The smoke pouring down into the cigarette. The fragments of a dropped plate assembling themselves on the floor and hopping into your hand. We laugh at these because they are absurd, impossible, never seen. Yet not one of them violates the fundamental laws of physics. Each reversed process is, atom by atom, perfectly permitted. So we face a riddle that seems almost paradoxical. How can a world built entirely from time-symmetric laws produce a reality so thoroughly, relentlessly one-directional? Where does the arrow come from, if not from the basic rules? The answer, worked out in the 1800s and refined ever since, lies in a single quantity called entropy, and understanding it requires distinguishing between two ways of describing any system. Consider a box of gas. You could, in principle, specify the exact position and velocity of every single molecule, an unimaginably detailed description, the microstate. Or you could describe the gas the way we actually do, with a few broad properties: its temperature, its pressure, its volume, the macrostate. The crucial point is that an enormous number of different microstates all correspond to the same macrostate. There are countless specific arrangements of molecules that all produce the same temperature and pressure. All look identical at the level we can perceive. Entropy is, at its core, a measure of how many microstates correspond to a given macrostate. How many distinct molecular arrangements would look the same from the outside? A low entropy state is special, achievable in only a few ways. A high entropy state is generic, achievable in overwhelmingly many ways. Now, the arrow of time emerges not as a law, but as a matter of overwhelming probability. And this is one of the most beautiful pieces of reasoning in all of science. Imagine a drop of ink released into a glass of clear water. At first, the ink is concentrated in one small region, a highly ordered, low-entropy arrangement, achievable in relatively few ways. As the molecules jostle about randomly, bumping and drifting, they spread. Before long, the ink is dispersed evenly throughout the water, a disordered, high-entropy arrangement, achievable in an astronomically larger number of ways. Why does the ink spread rather than stay clumped? Not because any law forbids it from staying clumped. It is simply that there are vastly, incomprehensibly more arrangements in which the ink is spread out than arrangements in which it is concentrated. Random motion explores arrangements blindly, and blind exploration almost always lands in the overwhelmingly larger set. The ink spreads for the same reason that shuffling a deck almost always destroys any order it had. There are simply far more shuffled arrangements than ordered ones. The second law of thermodynamics, which states that entropy tends to increase, is not a fundamental commandment of nature. It is a statement of statistics, of what is overwhelmingly likely when enormous numbers of particles move at random. And here is the resolution of the riddle. The arrow of time, the reason the future looks different from the past, is the direction in which entropy increases. The glass shatters rather than reassembles because the shattered, scattered state has vastly higher entropy than the intact one. Heat flows from hot to cold because the spread-out distribution of energy has overwhelmingly more arrangements than the concentrated one. Eggs break and never unbreak. Smoke disperses and never gathers. The cream stirred into coffee never separates back out. Every familiar one-way process is entropy climbing toward the more probable, more disordered arrangement. The arrow is not built into the fundamental laws, which remain perfectly time-symmetric. It is built into the statistics of large numbers, an emergent pattern that appears only when you stop tracking individual particles and start describing systems in bulk. The microscopic world has no arrow. The macroscopic world has a powerful one, and the bridge between them is entropy. But this answer, satisfying as it is, only relocates the mystery to a more fundamental and more troubling place, and the relocation is where the real depth lies. If entropy increases toward the future because high-entropy states are overwhelmingly more probable, then the same reasoning, applied in reverse, says entropy should also increase toward the past. Because the statistics are symmetric and do not know which way time points. Run the logic backward from any given moment, and it predicts that the past, too, should have been higher in entropy more disordered, more probable. But that is the opposite of what we observe. The past was not more disordered than the present. It was strikingly more ordered. Yesterday had lower entropy than today, last year lower still, and tracing the chain back, the entire universe must have begun in a state of extraordinarily, almost impossibly low entropy. The egg was whole before it broke. The cup was hot before it cooled. The order had to come from somewhere, and the statistical argument by itself cannot supply it. It can only explain why order, once present, tends to decay. This pushes the entire arrow of time back to a single, staggering fact about the beginning of the universe. For entropy to be increasing now, it must have been even lower in the past, and lower still before that. All the way back to the very first moments after the Big Bang, which must have been a state of breathtakingly low entropy. Extraordinarily ordered, extraordinarily special, achievable in only a minuscule fraction of the ways the early universe could have been arranged. Every arrow of time we experience, every broken egg and cooling cup and fading memory, every sense that the past is fixed and the future open, traces ultimately to that one initial condition. The arrow of time is, in the end, not a property of the laws of physics at all, but an inheritance from the peculiar low-entropy state in which the cosmos happened to begin. Why the universe started in such an exquisitely ordered, improbable configuration is among the great open questions of physics, and no one has a settled answer. Now bring this back to the block universe, because the connection transforms the whole picture. In the four-dimensional loaf, there is no flow of entropy, no process of increase actually happening. There is only a static distribution of entropy along the time axis, low at one end of the loaf and high at the other, fixed and complete like everything else in the structure. The block does not increase in entropy any more than a mountain range increases in height as you walk along it. The variation is spatial, already there, a gradient frozen into the shape. What we call the increase of entropy is simply the fact that the loaf is arranged with order at one end and disorder at the other. And this finally explains why we experience an arrow at all inside a universe that does not flow. We are physical systems embedded in the loaf, and our sense of time's direction is oriented along the entropy gradient baked into the structure. The arrow is not motion through the block. It is a feature of the block's contents, a difference between its two ends that we, as creatures living along that gradient, register as the difference between a remembered past and an unknown future. The block does not need to flow to have an arrow. It only needs to be lopsided in entropy, and it is. This reframing is powerful, but it leaves one piece conspicuously unexplained, and it is the piece that touches us most intimately. We have accounted for why glasses break and heat spreads. We have not yet accounted for why we remember the past and not the future. Why memory, that most personal evidence of time's flow, points only one way. The entropy gradient explains the physics of the loaf. It has not yet explained the experience of the being who lives inside it. If the future is as real and fixed as the past, why does it feel blank, open, undecided, while the past feels solid and known? To answer that, we have to turn from the physics of entropy to the physics of the brain itself, and ask what a memory actually is, and why the very act of recording the past may be the source of the entire illusion that time moves. What is a memory physically? Not what does it feel like. What is it as an object in the world? It is a record, a configuration of matter that carries information about an earlier state of affairs, a pattern of strengthened connections among neurons, a trace left in the brain by an event that has passed. And here is the question that cracks open the deepest layer of the whole mystery. Why do we have records of the past, but never of the future? Why does the brain accumulate traces in one direction only? The answer, it turns out, is the same entropy gradient that breaks the glass and spreads the ink. And once you see that memory itself is a thermodynamic process, the sense that time flows begins to look less like a window onto reality and more like a property of the recording device. Start by examining what it takes to make a record of anything, because the requirements are surprisingly strict and surprisingly revealing. To store information about an event, you need a system that can be reliably changed by that event, and then hold the change afterward. A camera's film is altered by light and retains the alteration. A footprint is the sand's record of a foot, the grains pushed into a configuration they will keep until something disturbs them. A memory is the brain's record of an experience, neurons rewired into a pattern that persists. In every case, making a record requires starting from a blank, ordered, ready state, fresh film, smooth sand, an attentive brain, and allowing the event to impose a pattern on it. The blank state is the crucial ingredient. You cannot record onto film that is already exposed, cannot take a clear footprint in sand already churned with marks, cannot lay down a clean memory in a brain with no capacity to register the new. Recording demands a low entropy starting point that the event can then disturb. This is the hidden link between memory and the arrow of time, and it is exact rather than metaphorical. Creating a record is itself an entropy-increasing process. When the camera captures an image, when the sand takes the footprint, when the brain forms a memory, the local order of the recording medium is purchased at the cost of a larger increase in disorder elsewhere. Heat released, energy dissipated, the total entropy of the system and its surroundings climbing in obedience to the second law. Recording is not exempt from thermodynamics. It is a special case of it. And because the formation of every record requires the entropy of the wider world to increase, records can only be made in the direction of increasing entropy. That direction is, by definition, the future. We have records of the past and not the future, for precisely the same reason that the glass shatters rather than reassembles. Both are expressions of entropy climbing from the ordered early universe toward the disordered later one. Memory points backward in time because memory is a thermodynamic process, and thermodynamic processes run only one way along the entropy gradient. Now the explanation deepens into something genuinely surprising. Notice that to recognize the very existence of a record, we must assume the past was more ordered than the present. A footprint is evidence that a foot pressed the sand earlier, but that inference only works because we know the sand started smooth. If the sand had always been a chaos of random bumps, a foot-shaped depression would carry no information at all. It would just be one more random bump among countless others. A record is informative only against a background of prior order. The reason any record in the universe tells us anything is that the universe began in that extraordinarily low entropy state we encountered at the end of the entropy story. The same special beginning that gives us the arrow of broken eggs also gives us the possibility of memory itself. Without the low entropy Big Bang, there would be no records, no traces, no memories, and therefore no creatures capable of noticing that time seems to pass. The flow of time, the sense of it, is downstream of the universe's improbable orderly birth. With this in place, we can finally assemble the full account of why a static block universe produces beings who are utterly convinced that time flows, and the account is both elegant and unsettling. You are a physical system embedded in the four-dimensional loaf. Your brain, at each point along your world line, contains a particular configuration, a set of memories, a snapshot of records accumulated up to that point. At an earlier point on your world line, your brain holds fewer such records. At a later point, it holds more. The records pile up monotonically along the world line in the direction of increasing entropy, because that is the only direction in which records can form. Now ask what it is like to be that brain at any given point. It finds itself in possession of memories of everything entropy earlier along its world line, and in possession of nothing about anything entropy later. It has access to a fixed past and faces a blank future, not because the past exists and the future does not, but because records of the earlier states are physically present in it, and records of the later states are physically absent from it. The asymmetry of memory is mistaken for an asymmetry of existence, and the sense of motion, the feeling of one moment giving way to the next, emerges from exactly this structure. Consider the brain at a particular point on the world line. Among the records it contains is a record of having been at the previous point, and that earlier record itself contained a record of the point before. Each moment of awareness includes, baked into it, the memory of the moments that came entropy earlier, nested like rings in a tree. So at every point along the world line, the brain is in a state of seeming to have just arrived from somewhere, of carrying the immediate past with it as a felt continuity. There is no actual motion required for this. Each slice of the brain along the world line simply contains, as a static fact, the records that generate the impression of having moved. The film analogy returns with full force. Each frame of a film is a still image, yet each frame, when it contains the right content, can depict motion and continuity. And a being made of such frames would feel itself in continuous motion even though every frame just sits in the can, complete and motionless. The flow of time is what the inside of the loaf feels like to a record-accumulating system embedded along its entropy gradient. It is real as an experience and absent as a physical process. This is a strange and demanding idea, and it is worth pausing to acknowledge how much it asks of us, because the resistance it provokes is not foolish. We are being told that the single most immediate, continuous, undeniable feature of conscious life, the relentless passage of the present, is something like an optical illusion, a perspective effect generated by the way memory is structured within a static reality. The claim is not that the experience is fake. The experience is perfectly real and is exactly what the physics predicts a creature like us should feel. The claim is that the experience does not reveal what it seems to reveal. It seems to reveal a moving present sweeping through time. It actually reveals only the arrangement of records inside a brain that occupies a fixed world line in a structure where nothing moves. The feeling of flow is evidence about the observer, not about time. And this places the flow of time alongside the spinning sky and the solid ground in that long catalog of intuitions that turned out to describe our viewpoint rather than the world. There is even a measurable strangeness in how the brain constructs the present, which lends weight to the idea that our temporal experience is a construction rather than a direct readout. The brain does not present the world to us in real time. Signals from different senses travel at different speeds and require different amounts of processing. Sound and light arrive and are handled on different schedules, yet we experience a single, unified, seamless present in which a clap is seen and heard together. The brain achieves this by holding incoming information briefly and assembling it into a coherent moment before delivering it to awareness, which means the now we experience is stitched together slightly after the fact. a constructed package rather than an instantaneous window. Our present is a production of neural machinery, edited and synchronized, not a raw glimpse of a passing instant. If the now itself is something the brain builds, then the flow connecting one now to the next may be just as constructed, assembled from the records each moment carries of the moments before. So the arrow of time, the directionality of memory, and the very feeling of temporal passage all resolve into features of an entropy gradient and the record-keeping systems that ride along it. The block universe absorbs them all without needing to flow. But absorbing the physics is not the same as absorbing the consequences, and one consequence looms over everything we have built, refusing to be quieted by any appeal to entropy or neural construction. If the future already exists, complete and fixed, sitting in the loaf as solidly as the past, then what becomes of choice? What becomes of the sense that the next moment is ours to shape? That we stand at a fork and decide which way to go? If the way we go is already written into the structure, already there before we arrive, then the question can no longer be postponed. We have to ask whether a frozen future leaves any room for free will at all. If the future already exists, then everything you are about to do is already done. The words you will speak tomorrow are sitting in the loaf right now, as fixed as the words you spoke yesterday. The choices you experience as open, turn left or right, speak or stay silent, take the job or refuse it, have outcomes that are not waiting to be determined, but are already there, already real, already part of the unchanging structure. This is the hardest consequence of the block universe to absorb, harder than the loss of the present, harder than the illusion of flow, because it reaches into the thing we most insistently believe about ourselves, that we are authors of our own next moment. If the next moment is already written, in what sense do we author anything at all? Confront the problem in its starkest form before searching for any relief from it. In the block universe, your entire world line exists as a completed whole. Every decision you will ever make is a feature of that world line, located at its proper place, no more alterable than the past. When you arrive at what feels like a fork in the road, the branch you will take is already the branch your world line follows. It was there before you reached the fork, and your deliberation, your sense of weighing options, is itself an event sitting fixed in the structure. The deliberation is real. It genuinely happens. It is part of the loaf. But its outcome was never in doubt from the structure's point of view, because the structure already contains the outcome. You feel as though you are deciding, but the decision, complete with the feeling of deciding, was always part of the four-dimensional shape that is you. Nothing you do can make the future different from what it is, because what it is already settled. This is the specter the block universe raises, and it cannot be waved away by saying the feeling of choice is strong. The feeling of flow was strong too, and the physics dissolved it. Yet before despairing, notice that this challenge is not new and not unique to the block universe, and recognizing that lifts some of its weight. Philosophers have wrestled with the conflict between free will and a determined future for over 2,000 years, long before relativity, because classical physics already posed it in a different guise. In the clockwork universe of Newton, where every particle's future motion is fixed by its present position and velocity through deterministic laws, the future was already settled in a different sense. Settled not as an existing structure, but as an inevitable consequence of the present. If you knew the exact state of every particle now, you could in principle compute every future state with certainty, including every thought and action of every human being, because thoughts and actions are, on this view, just patterns of particles obeying the laws. So determinism, the idea that the future is fixed by the present, was on the table centuries before the block universe arrived. The block universe changes the picture from the future being fixed by the present to the future simply being there alongside the present. But the core threat to free will, that what will happen is not up to us in the way we feel it is, was already ancient. This long history matters because it produced a response that applies directly to our problem, a position philosophers call compatibilism. And it deserves a careful hearing because it is the most developed answer available. Compatibilism argues that free will and a determined or fixed future are not actually in conflict, because we have misunderstood what free will means. The intuitive notion of free will imagines that to be free, your choice must be uncaused, must spring from nowhere, must be such that even with everything about you and your situation held exactly fixed, you could have done otherwise. But examine that notion and it dissolves into incoherence. A choice that springs from nowhere, uncaused by your character, your values, your reasoning, your desires, would not be your choice at all. It would be a random event happening to you, no more an expression of your will than a coin flip. Genuine freedom, the compatibilist argues, is not freedom from causation. It is a particular kind of causation, the kind in which your actions flow from your own desires, deliberations, and character, unimpeded by external coercion. To be free is for your choices to be caused by you, by your reasoning and values, rather than forced upon you by chains, threats, or manipulation. Apply this to the block universe, and the despair begins to lift. Yes, your choice is already there in the loaf. But what is the choice when you look closely at the world line? It is your deliberation, your weighing of reasons, your values producing an outcome. The fixed future does not bypass your decision-making. It includes your decision-making as the very process that brings the outcome about. The branch your world line takes is fixed, but it is fixed as the result of your deliberating, not in spite of it. Remove the deliberation, and the world line would be different. The deliberation is a genuine, load-bearing part of the causal structure, not a decorative illusion painted over a decision made elsewhere. You are not a passenger watching your fixed life unfold against your will. You are the author whose authoring is itself part of what is written. The choice is yours precisely because it issues from your reasoning, and the fact that your reasoning and its outcome already exist in the structure does not make them any less yours. A novel's ending is fixed once written, but the characters within still act from their own motives. The difference is that in reality, you are both the character and, through your deliberation, a genuine cause of how the story goes. This response is powerful, but honesty requires acknowledging what it does not save, and the compatibilist would agree on this point. It does not save the libertarian notion of free will, the idea that at the moment of choice the future is genuinely open, that multiple outcomes are really possible, that you could have done otherwise in the strongest sense, with everything held fixed. That notion is incompatible with the block universe, flatly and without remainder. In the loaf, there is exactly one future, the one that exists, and no alternative future sits beside it as an equally real possibility. The road not taken is not a faded second branch in the structure. It is nothing at all, a path that does not exist. If your sense of freedom depends on believing that, standing at the fork, both roads were equally real and you selected between two existing futures, then the block universe takes that belief from you, and no amount of compatibilist reframing gives it back. What you get back is a different and more modest freedom. The freedom of being the genuine source of your actions, even within a future that admits no alternatives. There is a temptation to slide from the fixed future into fatalism, and it must be resisted because it rests on a logical error, one worth dismantling carefully. Fatalism is the attitude that says, if the future is already settled, then my efforts make no difference, so why bother trying? If I am fated to recover from this illness, I will recover whether or not I see a doctor. If I am fated to fail, no effort will save me. This reasoning feels like it follows from a fixed future, but it does not, and the flaw is precise. The future is fixed, yes, but it is fixed including your efforts, not independently of them. The recovery that exists in the loaf is, in the vast majority of realistic cases, a recovery that comes about through seeing the doctor. The structure does not contain an outcome that will arrive regardless of what you do. It contains an outcome that arrives because of the specific chain of events, including your actions, that lead to it. To imagine that you will recover whether or not you act is to imagine a different world line, one in which you did not act, and that world line has its own, likely worse, outcome. Your actions are not bypassed by the fixed future. They are the means by which the fixed future comes to be what it is. Fatalism smuggles in the false idea that the outcome is fixed, while the path to it is free to vary. In reality, outcome and path are fixed together as a single woven thread, and your efforts are part of the weave. Step back, and the emotional texture of the idea shifts, perhaps unexpectedly, towards something other than despair. There is a strand of thought, reaching back to ancient philosophy and echoed by some who take the block universe seriously, that finds a strange consolation in it. Einstein himself, writing to the family of a friend who had died, offered words to the effect that the distinction between past, present, and future is a stubbornly persistent illusion, and he meant it not as a grim verdict, but as a comfort. If the past does not cease to exist, then those we have lost are not annihilated. They remain real at their place in the structure, their lives complete and permanent, not erased by the mere fact that our world line has moved past the region where they intersected ours. A life that has ended is not a life that has been deleted. It is a life that exists, fully and forever, in its stretch of the loaf, every moment of joy and meaning within it as real as it ever was. Whether this is genuine consolation or only a reframing, it shows that the fixed future need not be received as a sentence. It can be received as a kind of permanence. But all of this, the compatibilist rescue, the dismantling of fatalism, the consolation of permanence, rests on accepting that the future is genuinely fixed, that there is one block and it is complete. And there is a body of physics that seems to push hard in the opposite direction, that seems to insist the future is not fixed at all, that reality genuinely unfolds and outcomes are genuinely undetermined until they happen. That physics is quantum mechanics, and its strange behavior at the smallest scales appears, at least on the surface, to demand a real, flowing, branching present in flat contradiction to everything the block universe claims. If the future is already written, why does the quantum world look so undecided? The deepest tension in this entire investigation is the one we must now confront directly. If the future is already written, the quantum world did not get the message. At the smallest scales, reality appears to be radically undecided. A particle does not seem to have a definite position until it is measured. Before measurement, it exists in a haze of possibilities, a superposition of many locations at once, and only the act of looking seems to force it into one. This is the central strangeness of quantum mechanics, and it appears to demand exactly what the block universe denies: a real, flowing present in which undetermined possibilities become determined facts as time unfolds. If outcomes are genuinely open until the moment they occur, then the future cannot already exist, because there is nothing yet to exist. The quantum world looks less like a finished loaf and more like a story being written one word at a time, the next word truly unknown until the pen reaches it. This is the sharpest tension in our entire investigation, and resolving it requires looking carefully at what quantum mechanics actually says, as opposed to what it is often loosely described as saying. Begin with the experiment that displays the mystery most cleanly, the double-slit experiment, because everything hinges on understanding it precisely. Fire particles, electrons, say, or single photons, one at a time at a barrier with two narrow slits in it, and let them land on a screen behind. Common sense says each particle goes through one slit or the other and builds up two bands on the screen, one behind each slit. That is not what happens. Instead, the particles build up an interference pattern, many alternating bands of more and fewer impacts, exactly the pattern you would get from waves passing through both slits at once and overlapping, reinforcing in some places and canceling in others. This is bewildering enough for waves, but these are individual particles, sent one at a time, with long gaps between them so they cannot interact. Each lone particle, it seems, somehow goes through both slits, interferes with itself, and contributes to a pattern that only makes sense if it traveled as a spread-out wave of possibilities, exploring all paths at once. The particle behaves as though it has no single definite path until it strikes the screen. Now comes the part that seems to drag the flowing present into the very foundations of physics. Place a detector at the slits to catch which one each particle actually passes through. Do this, and the interference pattern vanishes. The particles revert to behaving like ordinary objects, each going through one slit, building up the two simple bands common sense predicted. The mere act of acquiring information about the particle's path destroys the superposition and forces a definite outcome. Before measurement, the particle is described by a wave function, a mathematical object encoding all its possibilities, spread across both slits. After measurement, the particle is somewhere definite. This apparent transition from a spread of possibilities to a single actuality triggered by measurement is called the collapse of the wave function, and it looks for all the world like a real event happening in time. An undetermined situation becoming determined, a possibility crystallizing into a fact, the future being written at the instant of observation. If collapse is a real physical process, then there genuinely is a moving boundary between the undetermined future and the settled past, and the block universe is in serious trouble. But everything depends on whether collapse is real, and here we reach one of the strangest facts about quantum mechanics. The theory's equations do not actually contain collapse. The core equation governing how quantum systems evolve, the Schrödinger equation, is smooth, deterministic, and, crucially, time-symmetric, exactly like the other fundamental laws we examined earlier. It describes the wave function evolving in a perfectly continuous, predictable way, with no jumps, no collapses, no sudden crystallization of possibility into fact. Left to the equation alone, the superposition never resolves. It just keeps spreading and evolving smoothly forever. Collapse is not in the mathematics. It is an extra rule bolted on by hand, a recipe that says, when you make a measurement, abandon the smooth equation, and instead have the wave function jump randomly into one definite outcome with probabilities given by its prior spread. This bolted-on rule works astonishingly well for predicting experimental results. Quantum mechanics is the most precisely confirmed theory in history. But the rule sits awkwardly outside the elegant deterministic core, and physicists have argued for nearly a century about whether it describes something real or is merely a convenient bookkeeping device. This argument is the problem of quantum interpretation, and how you resolve it determines whether quantum mechanics threatens the block universe or quietly endorses it. Consider first the interpretation that takes collapse to be a genuine physical event, the view closest to the one taught in introductory courses. On this reading, the wave function is real, superpositions are real, and measurement really does cause an abrupt, random, irreversible collapse into a single outcome. This view does seem to require a flowing present and an open future, because collapse introduces genuine, irreducible randomness into the world at the moment of measurement, and randomness that resolves only when measurement occurs means the outcome did not exist beforehand. If this interpretation is correct, the future is not fixed. It is genuinely open, populated by real possibilities that become actual only as collapses accumulate, and the block universe in its strict form is false. But this interpretation carries heavy and well-known burdens. It never specifies precisely what counts as a measurement, what physical process exactly triggers collapse, and why the smooth equation should suddenly be suspended. It introduces a mysterious dividing line between the quantum world that superposes and the classical world that does not, without saying where the line falls or what enforces it. And it sits uneasily with relativity, because a collapse that happens everywhere at once, instantaneously across all of space, requires precisely the universal present that relativity abolished. A real, instantaneous collapse needs a definite now in which to happen, and relativity says there is no such now. That last tension is the crucial one, and it cuts deeper than is usually appreciated. We established through relativity that there is no universal present, no objective fact about which distant events are simultaneous. But a wave function collapse, if it is a real physical event, must happen at some definite moment across the whole extent of the entangled system, which can be spread across vast distances. Two particles can be entangled such that measuring one instantly determines the state of the other, no matter how far apart they are. If that determination is a real collapse occurring at a definite instant, then there must be a fact about the simultaneity of the two measurements. Which one collapsed the pair first? And relativity insists there is no such fact, that different observers will disagree about the order. The collapse interpretation and relativity are pulling in opposite directions. One needs a now, the other forbids it. This is not a minor technical wrinkle. It is a deep structural conflict between the two pillars of modern physics, and it has never been fully resolved. The discomfort it generates is one of the strongest reasons many physicists suspect that collapse is not a real physical event at all. Which brings us to the interpretation that dissolves the conflict entirely by denying that collapse ever happens. The view known as the many worlds interpretation. Its proposal is radical in one respect and conservative in another. Conservative because it takes the smooth, deterministic Schrödinger equation utterly seriously and refuses to add any bolted-on collapse rule. The equation is the whole story, and it never collapses anything. Radical because following the equation faithfully leads to an extraordinary conclusion. If superpositions never collapse, then when a measuring device interacts with a particle in superposition, the device itself enters a superposition. One branch where it measured one outcome, another branch where it measured the other. And since the experimenter then interacts with the device, the experimenter enters a superposition too, splitting into a version who saw the first outcome and a version who saw the second. The superposition does not resolve. It spreads outward, engulfing the measuring apparatus, the observer, and eventually everything that interacts with the result. Reality branches. Every quantum measurement splits the world into all its possible outcomes, each branch a fully real, separate continuation in which one definite result occurred, and the inhabitants are unaware of the other branches. There is no collapse because nothing is ever eliminated. Every possibility is realized in its own branch of an ever-branching reality. What matters for our investigation is that the many worlds picture restores the block universe in full and, in fact, fits it perfectly. There is no collapse, no random event, no moment when an open future becomes a settled past. The entire branching structure, every world, every outcome, every observer, exists as a single, vast, deterministic, four-dimensional object, evolving smoothly according to an equation that does not distinguish past from future. The appearance of randomness, of an undetermined outcome resolving at measurement, is explained as the experience of an observer who, after a branching, finds themselves in one particular branch and cannot perceive the others. The future is not open. It is the totality of all branches, all already present in the structure. The flowing, undetermined present that the collapse interpretations seem to demand turns out, on this reading, to be the same kind of illusion as the flowing present of everyday life. A feature of how an embedded observer experiences a static, complete reality, not a feature of the reality itself. Quantum mechanics, in its cleanest interpretation, does not threaten the block universe. It enlarges it into a branching block of staggering size and hands it back intact. So the apparent contradiction softens into a genuine but unsettled question. Whether the quantum world refutes or confirms the block universe depends entirely on which interpretation of quantum mechanics is correct. And that question remains open, debated by physicists with no decisive experiment, yet able to separate the contenders. If collapse is real, the future may be genuinely open and the strict block universe false. If collapse is an illusion and the smooth equation tells the whole story, the block universe stands, grander than ever. The mathematics is identical in either case. Only the interpretation differs, which is precisely why the matter remains unresolved. But this very inability to decide raises a question that has been hovering behind everything we have examined and can no longer be deferred. If the block universe and the flowing universe predict the same observations, if no experiment yet performed can tell them apart, then is the block universe a discovery about reality, or merely one way of talking about it? Could any conceivable test ever prove which picture is true? Could any experiment ever prove the block universe true? This is the question that separates physics from philosophy, and it must be faced honestly, because the answer is not the confident yes that the preceding hours of reasoning might lead you to expect. A theory earns its place in science by making predictions that can be tested, observations that would come out one way if the theory is right, and another way if it is wrong. So we must ask, with full seriousness, is there any measurement, any conceivable experiment that would come out differently in a block universe than in a genuinely flowing one? If the two pictures predict exactly the same observations in every possible case, then the choice between them may not be a question physics can settle at all. And that possibility forces us to ask what kind of claim the block universe really is. The difficulty is stark, and it is worth stating without softening. The block universe and the flowing universe seem to predict identical observations for everything. In both pictures, you remember the past and not the future. In both, entropy increases, glasses break, clocks tick, the same equations govern the same particles. In both, you feel the present passing. The block universe says the feeling is an artifact of memory structure within a static reality. The flowing universe says the feeling tracks a real process. But the feeling is the same either way, and the equations are the same either way. And every measurement you could make is the same either way. Because the block universe is not a different physics from relativity. It is an interpretation of the very same physics. There is no equation in the block picture that differs from the equations in the flowing picture. There is only a different story about what those equations mean. And when two stories predict the same observations down to the last decimal, no experiment can choose between them, because experiments only ever measure observations. This places the block universe in a peculiar and uncomfortable category, alongside the interpretations of quantum mechanics we just examined. The many worlds interpretation and the collapse interpretation also predict the same observations. That is precisely why physicists have argued about them for a century without resolution. The block universe versus the flowing universe is a debate of the same kind. It is a question about what reality is like beneath the observations, in a region the observations cannot reach. Such questions are sometimes dismissed as merely metaphysical, meaning that they concern the nature of reality but cannot be decided by experiment. And some scientists hold that questions of this kind are not properly scientific at all. That if no observation can distinguish two pictures, then there is no real difference between them, only a difference in words, and the entire debate is empty. On this strict view, asking whether time really flows or merely seems to is like asking whether the universe doubled in size last night, while all rulers doubled too. A question with no observable consequences, and therefore, perhaps, no genuine content. But this dismissal is too quick, and seeing why is important, because it rescues the block universe from being a mere word game. The relativity of simultaneity is not an interpretation. It is an experimentally confirmed fact, woven into the satellites overhead and the particles in the atmosphere. And that confirmed fact has logical consequences that do not depend on interpretation. We saw in the Andromeda argument that the relativity of simultaneity combined with the absence of a preferred frame leads, by tight logical steps, to the conclusion that future events must be as real as present ones. That argument does not require any new experiment. It requires only the experiments already done, plus valid reasoning about what they imply. The block universe in this light is not an arbitrary story laid over neutral facts. It is the conclusion that follows when you take the confirmed structure of relativity and ask what must be true for that structure to hold. The flowing universe, with its single advancing present, is the picture that the experiments have actually ruled out, because a single advancing present requires a universal simultaneity that relativity has shown does not exist. The block universe is favored not because an experiment measured it directly, but because it is what remains standing after the experiments demolished the alternative. This is a subtle but crucial distinction, and it changes the character of the whole inquiry. Physics does not only advance by direct measurement, it also advances by determining which pictures of reality are logically consistent with what has been measured. The existence of atoms was accepted long before anyone could see one, because atoms were the only consistent explanation for a web of indirect evidence. The block universe occupies similar ground. No one has photographed the future sitting in the loaf. But the future's existence is the most natural, arguably the only fully consistent reading of a relativity that has been confirmed in 1,000 ways. To hold on to a flowing present, you must either reject relativity, which no evidence permits, or adopt one of the strange escape routes we considered, making existence itself relative to motion, or denying that simultaneity says anything about reality at all. Each escape route carries a cost at least as high as accepting the block. The block universe wins not by triumphant demonstration, but by being the survivor, the picture left standing when the others are weighed and found more costly. Still, intellectual honesty demands acknowledging the genuine escape routes that remain, because they are not yet closed, and a careful investigation does not pretend otherwise. There exist serious physical theories that attempt to restore a preferred frame of reference, a hidden universal present that relativity conceals but that nonetheless exists. Some interpretations of quantum mechanics, in their struggle to explain the instantaneous correlations between entangled particles, quietly reintroduce exactly such a preferred frame, a real cosmic now relative to which collapses happen even though we cannot detect it. If any such theory turned out to be correct, if there really is a hidden preferred frame that experiments simply have not yet revealed, then a flowing present could be restored, and the block universe would not be forced upon us after all. These theories are not the mainstream, and they pay their own steep prices, often requiring effects that travel faster than light through a frame we can never observe. But they exist. They are taken seriously by capable physicists, and they mean the door to a flowing universe is not bolted shut. It is merely very hard to keep open, and harder with each confirmation of relativity. There is also a frontier where the question may eventually become genuinely empirical. And this is where the matter turns from settled philosophy toward live physics. Relativity describes spacetime as a smooth, continuous block. Quantum mechanics describes matter as discrete and probabilistic. The two have never been fully reconciled, and physicists have long sought a theory of quantum gravity that would unite them, a deeper theory of which both relativity and quantum mechanics are approximations. In some approaches to quantum gravity, spacetime itself is not fundamental, but emerges from something deeper. And in a few of these approaches, the smooth four-dimensional block of relativity might turn out to be an approximation that breaks down at the smallest scales, replaced by a structure in which something more like genuine becoming, genuine flow, reappears at the foundation. We do not know. No theory of quantum gravity has been confirmed. The candidates remain unverified and in many cases untestable with current technology. But the existence of this frontier means the block universe is not necessarily the final word. It is the best reading of our current best theories, and our current best theories are known to be incomplete. The deepest layer of reality, where time may finally reveal whether it flows or merely sits, is still hidden from us. So we arrive at a measured verdict rather than a triumphant one, and that is the honest place to arrive. The block universe is not proven in the way that the existence of atoms is proven, by a convergence of direct and indirect evidence so overwhelming that no alternative survives. It is rather the most natural and most consistent interpretation of relativity, a theory that is itself confirmed beyond reasonable doubt. The flowing present, the one feature of reality we feel most certain of, has no place in the confirmed structure of space-time and survives only in interpretations that pay heavy prices to keep it. The future appears to be as real as the past. The loaf appears to be complete, and the passage of time appears to be a feature of observers rather than of the world. Appears, in each case, with the strong but not absolute confidence that the best available physics affords. This is not certainty. It is the considered judgment of where the evidence points, and whether it points truly all the way down, or only to the edge of a deeper theory we have not yet found, remains genuinely open. But suppose for a moment that it does point truly. Suppose the loaf is real and complete. Then we are left to ask what it would actually mean to live a single human life inside a universe where every moment of that life exists permanently and nothing ever truly passes away. Suppose the loaf is real, then your life is not a journey but a shape. Every moment you have lived and every moment you will live exists permanently, fixed in the structure, and you are the entire four-dimensional thread connecting them. Not a point traveling along that thread, but the whole of it, from first breath to last, eternally present in the fabric of reality. What would it actually mean to be such a thing? Not as an abstract physics claim, but as the truth about your own existence. This is where the block universe stops being a puzzle about clocks and trains and becomes something that touches the texture of a single human life. And it is worth following the thought all the way to its end, because the conclusions are not what intuition expects. Begin with the most immediate consequence, which is that no moment is ever lost. In the flowing picture, the past is gone, annihilated, surviving only as fading traces in the present. Every joy you have experienced has been destroyed by the passage of time. Every person you have loved and lost has been erased from reality, surviving only in memory and record. This is the ordinary, melancholy understanding of time that nearly everyone carries. The sense that life is a continuous hemorrhage of moments into non-existence. That to live is to watch everything you have be taken away instant by instant. The block universe denies this completely. In the loaf, no moment is ever destroyed, because no moment ever flows away in the first place. The afternoon of your childhood that felt, in the flowing picture, to be gone forever is not gone. It exists permanently at its place in the structure, as real as it ever was, complete with every sensation and feeling that filled it. The flowing picture says that moment has been annihilated. The block picture says it is eternal. Whichever is true, they cannot both be, and the block universe offers the more generous of the two. This reframing reaches its sharpest point in the matter of death, and here the block universe says something genuinely consequential rather than merely curious. In the flowing picture, death is annihilation in the fullest sense. The person who dies passes out of existence, their entire life swept into a past that no longer exists, leaving nothing behind but the memories of others and whatever marks they made before vanishing. The block universe describes death differently. Death is the end of a world line, the point past which the thread does not extend. But the world line itself, the entire life it represents, does not vanish when its final point is reached. It remains in the structure, complete and permanent, every moment of it as real after the death as before. Because reality does not erase the regions of the loaf that lie behind any particular vantage point. A life that has ended is, in this picture, not a life that has been deleted, but a life that is finished, in the way a book is finished when you reach its last page. The book does not cease to exist when you close it. The story it contains remains whole on the shelf. A person who has died is, in the block universe, exactly that. A complete story, permanently real, no longer being read by those who have moved past it, but in no way erased by the reading having ended. This is why Einstein could write, to comfort the grieving, that the separation between past, present, and future is only an illusion, however persistent. He was not offering an empty platitude. He was stating what his own physics implied. If the block universe is true, then those we have lost have not been annihilated. They exist at their place in the structure, their lives complete and permanent. The love and meaning and joy contained in those lives as real as anything is real, untouched by the fact that our own world line has carried us into a region where we no longer encounter them. Whether this constitutes genuine consolation is a question each person must answer for themselves, and it would be dishonest to insist that it removes the pain of loss, because the felt absence of someone, the inability to encounter them again along our own forward path, is real and is not lessened by knowing they exist elsewhere in the structure. But it does change the metaphysical fact of the matter. The flowing picture says the dead are nothing. The block picture says the dead are eternal, sealed in their stretch of reality, beyond the reach of any further loss, because what is finished cannot be taken away again. Yet the same permanence that consoles also unsettles, and honesty requires holding both faces of it at once. If every moment of your life is eternally fixed, then every moment of suffering is also eternal, never undone, never escaped, permanently real at its place in the structure. The flowing picture at least offers the mercy that pain passes into a non-existent past. The block picture denies even that, holding that the worst moments of a life are as permanent as the best, fixed forever in the fabric. And the fixedness extends to the shape of the life as a whole. Its length is settled, its turning points are settled, the moment of its ending is settled. And there is, in the strict block picture, no sense in which any of it could have gone otherwise. The life you have is the life that exists, the only one, with no alternative version waiting in some neighboring region of the loaf. This is a hard thing to hold alongside the consolation, and a careful account must hold it rather than hiding it. The block universe does not offer a gentle eternity of preserved joys with the suffering edited out. It offers the permanence of the whole, suffering and joy together, exactly as lived. There is, though, a way of receiving this that transforms it, and it has been arrived at independently by thinkers across many centuries who never heard the words block universe. If every moment exists permanently and eternally, then every moment matters permanently and eternally. The afternoon of ordinary happiness, the conversation that seemed trivial, the small kindness offered and forgotten, none of these are lost into a vanishing past, to be outweighed and erased by what comes after. Each is sealed into the structure of reality forever, given a permanent place, made eternally real by the very fixedness that can seem so cold when first encountered. The flowing picture, for all its intuitive comfort, is in one sense crueler. It says that everything you do dissolves the instant after you do it, that the present is a knife edge of existence with annihilation on both sides, that nothing you experience is kept. The block picture says the opposite. It says that nothing is kept because nothing is keepable in a flow, but everything is kept because nothing flows. Every moment is held. The structure forgets nothing because the structure does not move and therefore cannot leave anything behind. This suggests a particular orientation toward living, one that follows from the physics without being commanded by it. If each moment is permanent, then the quality of each moment is permanently part of what reality contains. The way you inhabit an ordinary Tuesday is not a transient event that will be erased by Wednesday. It is a permanent feature of the four-dimensional whole, a region of the loaf that will always have been exactly as you made it. This does not mean the future can be changed, because it cannot. The loaf is fixed. But it means the moments you are living are not being spent and discarded. They are being established, written into a structure that will hold them forever. The deliberation we examined earlier, the genuine causal role your choices play in shaping which world line is yours, takes on a different weight in this light. You are not choosing between alternative futures, since only one future exists. But your choosing is the process by which that one permanent future comes to have the character it has, and that character is eternal once established. You are, in a real sense, not passing through your life, but composing it, contributing to the permanent shape of a reality that will always contain exactly what you put into it. None of this softens the strangeness of the underlying claim, and it should not be made to. We are still talking about a universe in which time does not move, in which the future is as real as the past, in which the most immediate feature of conscious experience is an artifact of how memory is arranged within a static structure. This remains one of the most demanding ideas in all of science, asking us to set aside a conviction so deep we absorbed it before language. But the demand is not arbitrary. It comes from following the best confirmed physics we have to its natural conclusion, and the picture that results, however strange, is internally coherent and, in its own austere way, not without consolation. The block universe takes from us the flowing present and the open future, and in exchange it offers permanence, a reality in which nothing experienced is ever truly lost, in which every life is complete and eternal at its place in the structure, in which the question is not how to keep moments from slipping away, but how to fill the moments that will always have been ours. And this leaves one final question, the one toward which the entire investigation has been moving. Not whether time is written, but what it means that we, the readers, can never see more than the single line we are presently reading. We can never see more than the line we are presently reading. That is the final and strangest feature of the block universe, the one that survives every argument and every consolation. If the loaf is real and complete, every moment existing permanently, then the deepest question is not why time is written, but why we experience it the way we do, sequentially, one moment at a time, never able to see the whole at once, always confined to a single advancing line of a text that is, in its entirety, already finished. We are readers who can perceive only the word our eye currently rests on, who carry memory of the words behind, but no sight of the words ahead, moving through a book that was complete before we opened it. Why this? Why in a static four-dimensional reality is there experience at all? And why does that experience take the peculiar form of a journey through a structure that does not move? This question marks the boundary where physics, having brought us this far, can carry us no further, and it is important to be clear about why. Everything we have established, the relativity of simultaneity, the four-dimensional structure, the entropy gradient, the asymmetry of memory, explains the physical facts of the block universe. It explains why records point backward, why entropy increases in one direction, why a physical system embedded in the loaf would process information sequentially. What it does not explain, what no current physics explains, is why there is something it is like to be such a system at all. Why the static structure is not merely a static structure but is, from the inside, experienced. The hard problem of consciousness, as it is called, is unsolved in any universe, flowing or static. But the block universe sharpens it to a fine point, because it strips away the easy assumption that experience is simply what happens as time flows. In the block universe, time does not flow, and yet experience happens. So experience cannot be the flowing of time. It must be something else, something the physics describes the substrate of, but not the substance of. Consider what the block universe actually requires of consciousness, because the requirement is precise and strange. Your world line is a fixed thread through the structure, and at every point along it, your brain is in a particular state, containing particular records. The physics says these states exist, all of them, permanently. The early ones and the late ones equally real. But your experience is not of all of them at once. You do not experience your whole life as a single timeless totality, the way the structure contains it. You experience it as a succession, a here and now that seems to advance, a single present moment that feels selected out of all the moments as the one you are in. Where does that selection come from? The structure does not contain a marker singling out one moment as the experienced one. Every moment along the world line is equally there, and presumably every moment is equally experienced, each brain state along the thread having its own experience of being the present. There is no single now being illuminated as the structure sits still. There is, rather, an experience at every point, each one feeling itself to be the present, each one carrying memories of the points behind and facing the blankness of the points ahead. This leads to a conception that is difficult to hold steadily in the mind, but follows directly from the premises. Perhaps there is no single you moving along the world line at all. Perhaps there is, instead, a whole series of momentary experiencers, one at each point along the thread, each complete in itself, each feeling like the present moment, each containing the memories that make it feel continuous with the ones before. The you of this morning and the you of this evening are not the same experiencer at different times. They are different experiences at different places in the structure, linked by the memories the later one contains of the earlier. The sense of being a single self flowing through time would then be, like the flow of time itself, a construction, an effect produced by the fact that each momentary experiencer contains records of its predecessors and therefore feels itself to be their continuation. The unity of the self across time on this view is not a thing that travels through the loaf, but a relationship among the many experiences distributed along the world line, each one a separate lighting up of awareness that mistakes itself through memory for a single traveler. This is speculative, reaching beyond what the physics can confirm, but it is the kind of picture the block universe seems to invite when followed to its end. And here the investigation turns back on itself in a way worth noticing, because the very feature that makes the block universe so hard to accept may be the feature that makes it livable. We cannot see the whole loaf. We are confined at every moment to the single line we are reading, blind to what comes next, carrying only the past in memory. If we could see the whole, if every experiencer along the world line perceived the entire fixed structure of their life at once, every joy and suffering and the precise moment of the end all present together, it is not clear that such a being could function or choose or feel the engagement with life that the forward-facing, future-blind perspective makes possible. The confinement to a single advancing line, the inability to see ahead, the sense of an open future even within a fixed structure, these may not be limitations imposed on us by some defect of perception. They may be the very conditions that make experience, deliberation, and a meaningful life possible at all. The block universe is fixed, but it is built so that its inhabitants cannot perceive the fixedness, and that blindness is not a flaw in the design. It is what allows the inhabitants to live their lines as though they were being written, which from the inside is indistinguishable from actually writing them. So we return, at the end, to the question we began with. and find it transformed. We asked whether time moves forward or whether it is already written, and we have followed the physics to an answer that is as firm as the evidence allows and as humble as honesty requires. The flowing present, the moving now, the open future receding before us. These find no place in the confirmed structure of relativity, which describes a four-dimensional whole in which every event has its permanent address and nothing moves. The future appears to be as real as the past. The passage of time appears to be a feature of observers embedded in an entropy gradient, generated by the one-directional accumulation of memory, not a feature of the world itself. The loaf appears to be complete. This is not certainty. It is the considered reading of our best theories, theories we know to be unfinished, with a deeper layer beneath them where the final nature of time may yet prove to be something we have not imagined. The honest verdict is that the block universe is the most natural interpretation of physics as we currently have it, favored not by direct sight, but by being the picture left standing when the alternatives are weighed. But notice what the block universe does not take from you, even if it is entirely true. It does not take away the genuine causal role of your choices, which remain the real process by which your one permanent future comes to have its character. It does not take away the meaning of your moments, which it makes eternal rather than transient, held forever in a structure that forgets nothing. It does not even take away the experience of flow, which is as real as any experience can be, and is exactly what the physics predicts a being like you should feel. What it takes away is only the belief that this flow is a fact about the universe, rather than a fact about you. And in exchange, it offers a reality in which nothing experienced is ever lost, in which every life is complete and permanent at its place in the whole, in which the past has not been annihilated, and the dead have not been erased, but exist eternally in their stretch of a structure that holds all things equally. Whether time moves forward or was already written, you are living the only line you can see, reading it word by word, unable to glimpse the next. And perhaps the deepest lesson of the block universe is that this, the forward-facing blindness, the single advancing line, the sense of a future not yet arrived, is not the opposite of a written universe. It is what a written universe feels like from the inside, to the only kind of reader who could ever exist within it.